Randomness is always an important topic in software development. We only operate with pseudo-randomness in programming, because what really is truly random? Okay, let's not get too much into philosophy, but as Donald Knuth, a famous computer scientist, once said, random numbers should not be generated with a method chosen at random. And especially in the world of blockchains, secure randomness is a difficult thing to achieve. So why is it so hard? Well, transactions in Ethereum have to be deterministic. That's why we needed the oracles, if you remember. So you cannot just let nodes generate random numbers when verifying transactions, because they would all generate different random numbers. If we're all generating the same random number, then the random numbers wouldn't be very random at all, meaning they would be completely predictable. So what can we do instead? There are a couple of block variables in Solidity that one might think can be used as random numbers. In Solidity, you get access to the block's number, timestamp, difficulty, gas limit, and coin base. So number is just counting the blocks up. So this would be terrible for randomness. Timestamp is a value showing the time the block was minted. So could we use that for randomness? Absolutely not. The miner can choose his value himself. Okay, so then we have difficulty. So the minimum trailing zeros in a block hash. But that's not good either, since it changes in a somewhat predictable way. And then we have gas limit. So that's something we haven't talked about yet, but in Ethereum, you have a gas limit per transaction that we already talked about, but you also have a gas limit per block. This number can be changed by miners over time and has been increasing slowly over the last few years. Okay, it's obviously then not great for randomness either. And lastly, the coin base is the address of the miner that receives the current block reward. So not a great randomness choice, obviously either. So what if we add a private seed to the contract? And then the resulting number can be computed with a passed variable and the private seed stored in the contract. Well, this would be a great idea, but it's technically not possible. We operate in a public network and storing private data is simply impossible. Even if we declare state variables as private, someone just reading the raw bits on the outside can easily read a private variable and would be able to predict the random numbers. So that's not an option. So what about using the block hash then? Technically, it's also a block variable, of course, but it deserves its own section. And you can use it with the block hash function in Solidity. So yeah, maybe you can already guess now that we might be able to use this for randomness somehow, but you do need to be aware of the details. So first of all, the block hash of which block are we actually using? You pass the number of the block you want to read to the block hash function in Solidity. So if we pass block.number -2, it will give us the block hash from 2 blocks ago. This would work, but it's obviously terrible for randomness because this block hash here is now already known to everyone because it was already mined. On the other hand, if you try to read the current block hash or one that is even in the future, well, then Solidity just returns 0 because it only works for past blocks because, well, future blocks naturally don't have a hash yet because they don't exist yet. But what we can do is we can use a future block hash if we require multiple transactions. So then you would first store the block number, for example, in a mapping like here, and block hashes to be used. We would first store a block number that we then use later on. So I would at least use +2 here for extra security, so you can know for sure this block hash here is not yet known at the time when you're running this code. And then later, in a second transaction, once the block with that number here was mined, you can calculate the random number as the block hash from that block and convert it into a uint256. But keep in mind, this check here for if random number equals 0 is actually essential, because Solidity can only look back at the last 256 blocks. So if, for example, someone waits too long and this block number here is already more than 256 blocks old, then this block hash here would return 0 even though it's already a mined block. So then you do have to handle this case specifically if random number equals 0. This has actually been a hack for a smart contract called Smart Billions, which was one of the first decentralized lotteries. So definitely pay attention to that. So can we always just use a future block hash? Well, it depends. Are you allowing gambles with winning amounts higher than the block reward? Then be aware of minor manipulation. If we assume a block reward of, let's say, 3 ether, any gamble for more than 6 ether actually gives miners an incentive to cheat on the gamble. While a miner cannot freely choose the hash for a block, he may choose not to publish a newly found block hash, and so has some kind of influence on the randomness. If he was playing in the lottery, for example, with a 50-50 chance to win, now he finds a new block himself where the hash would result in a random number of him losing. Well, now he just ignores this hash. And while that may not sound like a very big advantage, think about normal casinos and roulette. The bank here also has just a very small edge, but over time it's enough so that the player always loses. Fortunately, there are also a few other alternative solutions for randomness, which we will look at next.